All right, so we're on 512, solving equations by factoring. So we've already learned how to factor everything out. We're really good at it. We've memorized it. And now we're taking that one step further. We're going to have it factored, and then we're going to solve it that way. So if you remember the multiplicative property of 0, that says if A equals 0 or B equals 0, then AB equals 0. We know that because whatever A is, if that's 0, then it doesn't matter what B is, because then it'll still be 0, and likewise for B. If you did not remember this, now you do. Okay, this works backwards as well. It's called the zero product property. So we're learning another property that's kind of backwards from it. So the zero product property says that for all real numbers A and B equals 0 if and only if A equals 0 and or B equals 0. Now, so either A has to equal 0 or B has to equal 0, or both of them, because 0 times 0 is still 0. So a product of factors, so this is saying a product of factors because two factors are being multiplied by each other. So a product of factors is 0 if and only if one or more of the factors is 0. So as long as one of the factors is 0, everything's going to be 0, because 0 times anything is 0. So we can use this to help solve our equations. So we're going to start out a little bit easier. It's already in factored form for us, so we don't even have to factor. So that is really nice. If it wasn't, then we would. So we can think of this. So we have our first factor, right? And we have our second factor, okay? So if this first factor, x plus 2, equals 0, then it doesn't matter what x minus 5 is. That's going to equal 0, or the whole thing's going to equal 0. So we're going to basically split them up. So we're going to say x plus 2 equals 0, because we know, again, we know if this right here, this factor, if that equals 0, then when we multiply it by whatever x minus 5 is, we will get 0. And then we're also going to do x minus 5 equals 0, because we know if this x minus 5 is 0, it doesn't matter what x plus 2 is, it's 0. So you got to think of these as two factors. You remember how I talked about the factors? They're being multiplied together. They're in the parentheses. They're a unit. They stay together. So now that we separated them and set them both equal to 0, oops, I was just trying to get something off my screen. Oh no, where did it go? Oh gosh. Okay, that was a disaster. Not really disaster. Okay, so, oh Lord. Hold on. Technical difficulties for Miss Robinson. Okay, equals 0, x minus 5 equals 0. So we're going to solve for both of them. So in order to solve for x, subtract 2 from both sides. So x equals a negative 2. And then this one I'm going to add 5 to both sides to get x equals 5. So the way we can write our answer for our solution, we're solving the problem, so that means we're finding x. X equals a negative 2, comma 5, or 5. Doesn't matter, like either one, it's negative 2 or 5. Or you might see it written as a solution set, which it has this like squiggly kind of bracket thing, and it's negative 2, comma 5. So those are both ways to write it. So a lot of times the book likes to write it like this. So I'm just showing you either way. I will accept either way unless I say write it as a solution set. So there. So why is it not scrolling down? Okay, there we go. So number 2. Again, ooh, look, we have 3 factors this time. So we have the 5n, that's 1 unit. We have n minus 3, and we have n minus 4. So we have 3 factors. So we're going to set each one equal to 0, because if one of those factors equals 0, 0 times anything will give us 0. So we're going to set 5n equal to 0. We're going to set n minus 3. 3 equal to 0, and n minus 4 equal to 0. So now we're going to find, okay, if I divide by 5 on both sides, 0 over 5 is 0. So n equals 0. Add 3. So n equals 3, and add 4. So n equals 4. So our answers are n equals 0, 3, 4, or 4, or our solution set would be written as 0, 3, and 4. So that would be our answer. Oh no. Number 3 requires us to factor. So the other two, they factored it for us, so it made our life so much easier. But now, we need to factor. But this is easy. We know how to factor. So, we're going to factor the left side, okay? So, we know that it needs to add to that negative 11 and multiply to 18. So, what two numbers? 2 and 9, okay? But they both have to be negative because we need to add to negative 11. So, since this is the add multiply, we're just going to write it as p minus 2, okay, minus, I don't know, okay, it does not like me, okay, p minus 2, p minus 9, okay, so we just factored out the left side, but it's still going to equal 0, didn't change the problem, so now we have our two factors right here, okay, look at that. So we're going to set them both equal to 0. So p minus 2 equals 0, and p minus 9 equals 0. So we know that's going to be p equals 2, p equals 9. So our answer is p equals 2, 9, or, 2, 9. So those are our answers. Okay, last example, number 4. Okay, you can kind of see it right now. Again, technical difficulties with my computer scrolling down. Okay, there we go. Oh, we need to equal 0 on one side, okay? So we need it to be set equal to 0. So we're going to subtract 25 from both sides. Also, it'll help us factor. So we have 16x squared minus minus 25 equals 0. Ooh, this is the difference of squares. Do they have a GCF? No. Okay, so we're just going to do difference of squares. So I know that's going to be 4x minus 5 and 4x plus 5. So that's going to equal 0. So we have both of our factors, so we're going to set them both equal to 0. So we have 4x minus 5 equals 0 and 4x plus 5 equals 0. So I add 5 to both sides to get 4x equals 5. Divide by 4 to get x equals 5/4. And then I'm going to subtract 5 from both sides on this one. So 4x equals a negative 5. Divide by 4. So x equals negative 5/4. So our answers are x equals a negative 5/4, comma 5/4. Or we can write it in our solution set. So negative 5/4, 5/4. So you see how I told you you need to have it already and you need to know how to factor, because sometimes you can't solve the problem if you don't know how to factor. So, important. Okay, there we go.